Okay, in this video we're going to do some very simple charge conversions and then figuring out what the charge on objects would be if we touched them. So if they had different charges and then we touch them, what charge would they have and how many electrons got transferred. So that's basically what we're going to be doing. So let's calculate the charge first of all. Calculating charge is basically just a dimensional analysis, and the conversion we need to know is that the charge on an electron, so one electron has a charge of 1.6 times 10 to the minus 19 coulombs. So that's a conversion factor that we're going to be using. So if we have a charge of positive 6 microcoulombs, okay, first thing we need to do is change our microcoulombs to coulombs. So that means that we have positive 6 times 10 to the minus 6 coulombs, because micro, the prefix micro, means 10 to the minus 6. Okay, so it's a dimensional analysis problem. 6 times 10 to the minus 6. Set up our t-bars, coulombs. So where are we going to put coulombs so they cancel? 1.6 times 10 to the minus 19 coulombs is 1 elementary charge, is technically, because since this is positive, what is that elementary charge? It's not electrons. This elementary charge is a proton. Charge on a proton is exactly the same as the charge on an electron, just the opposite charge. So now we just do the math and we get the answer. This comes out to 3.75 times 10 to the 16, and since it's positive, this is going to be protons. Or it could be missing electrons. So if you have a positive charge, you are either missing electrons, or we're just talking about how many protons you have. So what if we wanted to find the charge on 6.02 times 10 to the 23rd electrons? That number might look familiar. That's a mole of electrons. So we're going to start off with our given. And we know that one electron has a charge of 1.6 times 10 to the minus 19. Okay, so do a little bit of, your properties of powers. 10 to the 23rd, 10 to the minus 19. We're multiplying, so we add them. So our answer should be on the order of 10 to the 4th. Let's see what it comes out to. So we get 96,320 coulombs. Now, little technicality, since they're electrons, are they going to be positive or negative? It's going to be negative. So make sure you pay attention. Electrons are negative. Protons are positive. Protons are positive. So that's easy enough, right? Alright, so here's an example of that conservation of charge thing. We have two spheres, okay? One of the spheres has a charge of positive 6 microcoulombs. So let's see, does it have extra electrons or is it missing electrons? Remember, electrons are negatively charged. Okay, if you're positive, you're missing electrons. So this is missing electrons. And there's another sphere with a charge of negative 4 microcoulombs. So since it's negative, it actually has extra electrons. So we're going to touch these to each other, or we're going to connect them with a conducting wire so that charge can flow from one to the other. So this brings up an important thing. What can flow? Can the positives flow? Okay, remember the atom. Okay, our protons are down here in the middle of the atom and our electrons are way out here. Okay, so are those protons in the middle of the atom available to move? No, just those electrons can move. So the electrons are going to go from the negative to the positive. So the electrons will always flow in from the negative thing to the positive thing. So our electrons are going to flow until they have the same charge. And that's kind of the tricky part. Till they're the same charge. Now, it actually doesn't seem like it's really easy. What is that same charge? The same charge actually happens to be the average of the two charges. So the equilibrium charge, where they come together, where they're equal, will be the average of the two charges. And you do have to include the sign when you're finding your average. So we have a positive 6. Remember, when we find an average, we add them up and divide by how many we have. Positive 6 and a negative 4 divided by 2. So that's going to come out to a positive 1 microcoulombs. So that's what charge they are both going to have. So when they're done transferring the electrons, when the electrons are done going from the negative to the positive, both spheres, this sphere and this sphere, will have a charge of a positive 1 microcoulombs. Okay, so we answered that part. Check, done, yay! Okay, how many electrons were transferred? That's a little trickier to find. So, do you see that we went 5 microcoulombs? So we went from a positive 6 to a positive 1. So we actually have a change in charge of 5 microcoulombs. Do you see that? And even if we looked at the other one, we went from negative 4 to a positive 1. That's still a change of 5. Okay, the difference between those two numbers is 5. Okay, so now it's just like the problems we did before. We're going to take that 5 microcoulombs. Okay, remember 5 microcoulombs is 5 times 10 to the minus 6 coulombs, because micro means times 10 to the minus 6. And then we're going to do our dimensional analysis. 1.6 times 10 to the minus 19 coulombs is 1 electron. Doing the math, we get 3.125 times 10 to the 13. Now here's a little hint, but let's powers of exponents. Let's do that. When we divide, we subtract. So negative 6 minus a negative 19. That's 6 plus 19. Negative 6 plus 19 is 13. Hey, look, that's what we got, 13. So we should get 12, 13, 14, somewhere around there for our power. You will never get, this is a little hint, you've done it wrong, you will never get a 10 to the minus electrons, because you can't have part of an electron. You can only have whole number multiples of the 1.6 times 10 to the minus 19. That is our elementary charge. That's the smallest charge we can have. We can't have 1.5 of them. We can only have multiples of it. So we can have 3.2 times 10 to the minus 19. Okay, that's multiplying it by 2. We can have multiplied by 3, and that would be 4.8 times 10 to the minus 19 coulombs. But we can't have 4 times 10 to the minus 19, because that's not a whole number multiple of 1.6 times 10 to the minus 19. This would be 2 electrons. This would be 3 electrons. You can't have a fraction of an electron. Okay, so that should get you started, and you should be well on your way to being able to start your forces and electrical charge worksheet.